So in this video, we're going to look at solving quadratic equations using factoring. We have learned how to factor before, so that's going to come back into play here. So hopefully we all remember that. The most important thing is that when you're going to solve a quadratic equation using factoring, that equation has to get put into standard form and has to be equal to 0. Has to. Before you can factor. So that's really important. So to review, we have a couple of different names for the solutions to a quadratic function. One of them is the roots of a quadratic function. Another one would be the x-intercepts. And then the third one would be the zeros. So all of those words mean the same thing as the solution to the quadratic function. So the zero product property, all that really means is any number multiplied by 0 is always going to be equal to 0. Or any parenthesis, I could put 0 here, I could put it here, I could put it here. It still makes that whole equation equal to 0. So that's going to come in and help us a little bit later. Okay, so here I have two different equations, and they're already factored. They're equal to 0. So we're going to solve them. All you're doing is taking anywhere that you have x, whatever the variable might be, whether it's inside of a set of parentheses or whether it's outside, and you're going to take that and you're going to have that set equal to 0. So I have an x right there, so I have 3x minus 2. All of that is going to get set equal to 0. And then solve for x. So in that case, I would get x is equal to 2/3. I have somewhere else that I have x. I have x right here on the outside, so I need to deal with that also. So I can say that 2x is equal to 0. So for that first problem, I would get two solutions, x equals 0 and x is 2/3. Now for the second one, I only have x in one spot. I have it inside of the parentheses. I don't have it out there like I did before. So you'll only be taking 3x minus 2 and setting that equal to 0. And then solve for x. So 2/3 or 0.67. So that's the difference in those two equations that look very similar. So we're looking anywhere that we have x. Okay, so let's look at another example now. Now, if you remember before, if you have y equals or f of x equals, we can replace that with 0. Okay, so we've got standard form, and it's equal to 0. So now I can try and factor. So now I kind of have to dig back a little bit and remember what we did when we were factoring. So we looked for two numbers that would multiply to 15, but then those same two numbers would have to add to the middle number, so in that case 8. So let's just start listing numbers that multiply to positive 15. 1 times 15, but when I add them, I get 16. Negative 1 times negative 15, when I add them, I get negative 16. I can do 3 times 5. When I add 3 plus 5, that equals 8. So that's what I want. So that means my numbers, we will set up x plus 3 and x plus 5 equals 0. So now anywhere that we have x, we set equal to 0. So we'll set that part equal to 0. and you get x equals negative 3. We set over here equal to 0. So we get x equals negative 5. So those are our two solutions to this quadratic equation. So now we remember the solutions, the roots, the zeros, the x-intercepts. That's where the parabola is going to cross the x-axis. So if we graph to this function, it should be crossing the x-axis at negative 3 and negative 5. So let's take a look at that graph. Right here, we can see that this graph crossed at negative 3 and negative 5. So that is what our parabola should look like. So let's look at another example. Make sure that we have it in standard form and that is equal to 0. So that's the problem that I see here. It's not equal to 0. So I'm going to have to add 4 and add 4. The reason I didn't put that 4 underneath anything is because it wasn't like terms. So now in standard form, it would be x squared plus 4x plus 4 is equal to 0. So when you would factor that, it would factor to x plus 2 and x plus 2. Because 2 times 2 is 4, 2 plus 2 is 4. So we're looking for numbers that multiply to 4, but add to 4 also. Okay, so now we have x plus 2. Set it equal to 0. X would equal negative 2. Once again, x plus 2 equal to 0. X equals negative 2. So our solution, or our root, or x-intercept, is x equals negative 2. So if we took a look at that graph, it should cross the x-axis at just negative 2. Only one spot. So here is that graph. It crossed at just negative 2 in that one spot. Okay, let's look at another one. Once again, this is not equal to 0. So subtract 49 from both sides. 36x squared minus 49 is equal to 0. Now I can try and factor. Hopefully, we see that this is a difference of perfect squares. We remember that from before. So the square root of 36, 6 and 6, x and x. Square root of 49, 7 and 7, 1 plus and 1 minus. So that's what that would factor to. And then that's equal to 0. So now we have to take our two parentheses, since they both have x in them, and solve for x. So our first one, 6x plus 7 equals 0. Subtract 7. So we get x is equal to negative 1.2. So then we'll take our other parenthesis and set that also equal to 0. So add 7 and add 7. 6x is equal to 7. And then I'll have to divide by 6. And I'm kind of running out of room here. So that's going to equal positive 1.2. So our solutions are x is 1.2 and x is negative 1.2. So that graph should cross at 1.2 and negative 1.2, that parabola, on the x-axis. Okay, so here's another example. We do not have this equal to 0, so we need to get it equal to 0. Remember, we want to try and keep the x squared positive, so that's why I'm subtracting the x and the 1. So in standard form, I would have 6x squared minus x minus 1 is equal to 0. Now I can't factor that normally because there's a 6 in front. So now we have to go back to divide and slide. So take the 6 over and multiply it. So this becomes x squared minus x minus 6 is equal to 0. Now I can factor, and that would become x minus 3, x plus 2. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1 in the middle. Now don't forget, if you slide, then you have to divide. So I slid by 6. So I have to divide by 6. Now that can simplify to x minus 1/2, and this becomes x minus 1/3. All right, not quite done. If you still have fractions, then we have to take the bottoms and slide them back in front. So our final factored version would be 2x minus 1 times 3x minus 1. Oop, that should be a plus 1. Okay, so now that we have it factored, I can take each of those parentheses and set them equal to 0. So I can have 2x minus 1 equal to 0. So I get 0.5 here. And then I will subtract 1, 3x is equal to negative 1. Divide by 3. X is equal to negative 0.3. So those are our two values. So if we graphed it, that parabola would cross the x-axis at 0.5 and negative 0.3. Okay, so if you would like to try a few problems here, you can, to get practice. After you finish those problems, then we're going to move on to another example. So this is one where we have a GCF. I know we might kind of have forgot about those, but we always have to check for the GCF first. So here, this is not equal to 0. First, I need to have it equal to 0. Getting that x squared term positive. All right, so now it's equal to 0. And these numbers are both even, so I know that there's at least a GCF of 2. So that would become 100x squared minus 49. Now there's no other GCF, but what I do see is that 100 is a perfect square and 49 is a perfect square, so this becomes a difference of perfect squares, and it would factor to 10x minus 7 and 10x plus 7. 10's from the square root of 100, 7's from the square root of 49. One sign's positive and one sign's negative. So now we're going to solve for x. Now you're only setting equal to 0 where we have x's. So we set this one and this one. You don't have to worry about that 2 on the outside because there's no x with it. So we have 10x minus 7 is equal to 0. Add 7, add 7. 10x is equal to 7. Divide by 10, divide by 10. X is equal to 0.7. And then our second one, 10x plus 7 equals 0. Subtract 7 to both sides. 10x is equal to negative 7, divide, and x is negative 0.7. So those are our two solutions here. So that's where that parabola would hit the x-axis. Okay, here's another example. Here we have a GCF and there's going to be a negative in front. So add 10x to both sides. Oops, got a little bit more straight. So you have negative 2x squared plus 10x plus 28 is equal to 0. Now we're going to have to take out a GCF of negative 2 because we can't have a negative in front. So that's going to become x squared plus 5x plus 14 is equal to 0. But hopefully you caught that if I'm taking a negative out, all of the signs are going to change. So those aren't going to be positive anymore, just like the front one wasn't negative anymore. So this is going to become a minus, and this is going to become a minus. So now we can factor the inside, and that can factor to x minus 7 and x plus 2. Negative 7 times positive 2 is equal to negative 14. Negative 7 plus 2 gives me that negative 5 in the middle. So remember, we're only setting equal where we have x. So we'll set that part equal and that part. Not the 2 out here because there is no x there. So x minus 7 equals 0 means that x equals 0. X plus 2 equals 0. X is negative 2. So our solutions are negative 2 and positive 7. And that's it for this video.